Hi everyone, so now we have studied most physics. Now it's time to solve an assignment. So there will be 4 to 5 questions there. So let me show you the questions. This is the first one. A MOSFET is given. You have to find V naught for two conditions. First, considering R equals to 1 kilo ohm, and second one R equals to 4.5 kilo ohm. Then there will be these 6 configuration. 2 configuration are there more. So you have to find the region of operation. Mu and Cx value is given. W by L value is given. Vt is given. These configuration are given. Values are given. Vgs value is given. So like that. You have to find the region of operation. 4 configuration, fifth, 6 configuration. The next one, this is the third question. You have to find that drain current of MOSFET. Drain current you need to find. That means this current you need to find. Drain current. These configuration is given. All those values are also given. Here also you need to find the okay. Here you need to find the RS value such that your MOSFET is working in saturation region. So how will you find that? You can try it. And then here you need to find the bias current in the transistor. What do you mean by bias current? Drain current only. So again you need to find the drain current only. So here again you need to find the ID value. I guess that's it. Yeah. So these questions are there. We will solve one by one. You might not be able to solve it if you are solving it for the first time, because if you are just watching the video of MOSFET for the first time, you might not be able to solve it. No worries. Even when I was the student, I was also not able to solve it. So let's start with the first question. Slowly you will develop the approach. Let's start with the first question. This is R equals to 1 kilo ohm. So we will take two conditions one by one. First we are taking R equals to 1 kilo ohm. So let's take R equals to 1 kilo ohm in the next page. This is circuit A. I will remove this R. This is 1 kilo. Now you don't know in which region MOSFET is working. You have the value, you have VGS value. This is gate, this is drain, and this is source. If there is no fixed potential, we have to assume, right? So we have assumed, like we have to assume in the given sense only. What is the given sense? What is the general sense? I told you what is the general sense. The general sense is, क्या हो रहा है writing pad? Yeah. So what is the general sense? General sense is this is gate, this is source, and this is drain, right? So we have to assume it in the same manner. Yeah. So what is the VGS value given? VGS value is 2 volt. What is the VDS value? You don't know, but that is V naught because source is grounded only. VDS is, and VT is 1 volt. VT is 1 volt. Now can you tell in which region the MOSFET is working? No. You don't know in which region MOSFET is working. So you have to assume. We will start by assuming this is working in saturation region. So this is my way. I always assume in saturation region. Then I see if it is working in saturation region only, and then I will decide. So this is my way, that I always start by assuming it in saturation region. You can start from linear region as well, but my suggestion would be always start from saturation region. So let MOS is working in saturation region. Let MOS is working in saturation region. So what will be your ID? What will be the ID? ID value will be mu n ux w by 2l vgs minus vt square. I guess this value is given mu n ux w by 2l. That would be 100 micro. So mu n ux into w by l, that is 2 milli actually. Okay, I will write down one by one. Mu n ux is 200 micro into w by l is 10 by 2. Always write down this micro, milli, kilo, always write it down. When you are solving the problem of MOS, always write it down along with. What is the value of VGS? That is 2. And what is the value of VT? That is 1. So what do you get? You are getting 1 milliampere. ID value you are getting 1 milliampere. Are you agreeing to this point? ID value is 1 milliampere, right? This value you got 1 milliampere. Now if this current is 1 milliampere, what will be the V naught value? What is V naught value? V naught value is 5 minus 1 kilo ohm into 1 milli. That would be 5 minus 1, that would be 4 volt. So V naught value came out to be 4 volt. But this is not your final answer. Now what did you do? You assumed here. You assumed MOS to be working in saturation region. So now you have to recheck if the assumption is correct or not. So what did you assume? You assumed the MOSFET to be working in saturation region. So now we will check in what region our MOS is working. So our V naught value is 4 volt. So now what is our VGS? VGS is fixed. That was 2 volt. What was our VT? VT was 1 volt. So what is my V overdrive? I told you what is V overdrive? V overdrive is VGS minus VT. V overdrive is VGS minus VT. I don't remember if I told you about this term or not. So V overdrive is VGS minus VT. Just nothing, just a term that is given to it. V overdrive. Just a simple term, nothing else. So V overdrive is 2 minus 1, that is 1 volt. So 4, and now what is VDS? VDS is 4 volt. Here VDS is equals to V naught only. VDS is equals to V naught only, that is 4 volt. So here what do you see? That VDS is greater than VGS minus VT, or directly we can write VDS is greater than V overdrive. So what do you understand by that? If VDS is greater than V overdrive, what do you understand by that? That MOS is in saturation. Saturation. So that means assumption, the assumption that we made, assumption correct, right? So the assumption that we made, that is correct. So if our assumption is correct, that means what is the final answer? What did they ask to find? You have to find the value of V naught. So V naught came out to be 4 volt. So here your final answer is V naught is 4 volt. Now take the condition of R equals to 5 kilo, sorry 4.5 kilo. If R is 4.5 kilo, what will happen then? R is 4.5 kilo. What will be your ID? So again what I will do, assuming, what will I assume? Assuming saturation region. Saturation region. Again I will assume saturation region. So what will be my ID? ID will be same value. ID will be same. Why so? Because ID depends on VGS minus VT, and VGS minus VT is fixed here. Or if you don't want to do it, you can start mu n Cux. Again I am assuming it to be saturation region. Mu n Cux W by 12 VGS minus VT square. What is mu n Cux W by 12? That is 200 micro into 10 by 2. 200 micro, W by L is 10 by 2. What is VGS? VGS is 2, VT is 1. So the current came out to be 1 milliampere. If the current is 1 milliampere, if this current is 1 milliampere, tell me what will be the value of V naught? V naught will be 5 minus 4.5 into 1. 4.5 kilo ohm into 1 milli, right? So V naught will be 0.5 volt. V naught will be 0.5 volt. Now, what will be the value of VDS? VDS will be VDS, drain to source. VDS will be V naught only, and that is equals to 0.5 volt. What is VGS minus VT? VGS minus VT. What is the value of VGS minus VT? VGS is 2 minus VT is 1 volt. Now what do you see here? Here VDS is less than VGS minus VT, right? Here VDS is less than VGS minus VT. That means it is working in linear region. This is working in linear region. So the assumption that we made, that is wrong. This is wrong. So assumption is wrong. What did we do? First we assumed that it is working in saturation region. So for saturation region we know the current equation. We applied that current equation. Then we got to know, after applying the current equation, we found the value of V naught. Then we got to know VDS value is 0.5 volt. So based on that, our VDS is less than VGS minus VT. That means our MOS is working in linear region, not in saturation region. So assumption is wrong. Now we will make another assumption. What assumption we can make? Now we will make an assumption that our MOS is working in linear region. Now you will say, sir, if it is not working in saturation region, it is certain that it should be working in linear region. So why we are calling it as assumption? It is assumption only, because it is not sure that it is working in linear region only. If it is not working in saturation, it can be in cutoff as well. So now you will write assuming linear region. You are not very sure that is linear region only. So again you will assume only, and then you will find the value of V naught, and then you can comment if your assumption was correct or not. Are you getting this point? Like I have seen many people directly write that now MOSFET will be working in linear region. So now we will apply linear region equation. But whether it will be working in linear region or not, that will depend on the V naught value that you get. So you can't really say that certainly it will be in linear region. No, assuming it to be in linear region. So again you will assume it to be linear region, in linear region, and then you will find the value of V naught, and then you can comment assuming linear region. Okay, so what is the equation in linear region? Do you remember what is the equation? Mu n Cux W by L, VGS minus VT into VDS minus VDS square by 2. This is the equation, right? You should be able to remember. Slowly you will remember if you don't remember. Okay, what is the value of ID? Look, do you know the value of ID? No. In case of linear region, you don't know the value of ID. Do you know the value of VDS? No, because VDS is also V naught. So there are two unknowns. But one thing you can see here is that 5 minus V naught by 4.5K is equals to ID. If this is ID, that means the same current is flowing through this resistance as well. So 5 minus V naught by 4.5K is equals to ID only. Are you getting this point? Simple network analysis here, right? So 5 minus V naught divided by 4.5K. I will certainly write K here. Why so? Because of the units. Unit पे गड़बड़ हो जाएगा, तो K लिखना ही है. We have to write K. Here I am writing mu and Cux. Then I will certainly write 200 micro into 10. What is VGS minus VT? That is 1 only. Because VGS is 2, VT is 1. That is 1 only. Into VDS is V naught minus V naught square by 2. Now my complete equation is in V naught only. Are you getting this point? So that's why I replaced ID with V naught. 5 minus V naught by 4.5K. So from here, what do you get? This is 2 milli 4.5 kilo. Look, what I will do, this value is 2 milli, and if I multiply 2 milli into 4.5K, then K and milli will be cancelled. K is 10 to the power 3, milli is 10 to the power minus 3. So they will make 1 only. So that will be cancelled. So that advantage I will take. 5 minus V naught, 4.5K into 2 milli, basically it will be 9. V naught minus V naught square by 2, right? So this equation we can solve. 4.5 V naught square, this is 10 V naught plus 5. V naught will be 10 plus minus B square minus 4AC, 100 minus 4AC. 4 into 4.5, that will be 9 into 4 minus 4.5, that is 18. 18 into 5, 90 by 2A by 9. Now you will solve it and you will get two values of V naught. So which value you will pick? Let me see the final answer. I might have written it. So what are the two values we get? 1.46 and 0.76. 1.46 volt and 0.76 volt. Two values we are getting. Now the question is which value you will take. So V naught value here I will write. We are getting two values of V naught, 1.46 volt and 0.76 volt. So which value you will take? How will you decide? If let my V naught is 1.4. If my V naught is 1.4 volt, what is my VGS minus VT? That is 1 volt. So here, and V naught is equals to VDS only in our question. So here VDS is greater than VGS minus VT. That means it should go into saturation. But it is not in saturation. That we have already seen by the previous analysis. By the analysis here, what we got to know that it is in linear region. It is certainly not in saturation region. That we have already seen. That it can't be in saturation region. So this case is not possible. This case is wrong. Because we already know that our MOS is not in saturation region. It can be in linear, it can be in cutoff, but certainly not in saturation region. So that condition is eradicated. Now let's talk about the second condition. If I take V naught equals to 0.76 volt, that is equals to VDS. What is the value of VGS minus VT? That is 1 volt. So here what do you see? VDS is less than VGS minus VT. VDS is less than VGS minus VT. That means it is in linear region. And the assumption that we made, that is correct. Assumption correct. So our V naught will be 0.76 volt. So that will be the answer. So many times these kind of questions are asked. You don't need to worry about these kind of questions. You don't need to what do we say, panic when you see these kind of questions. The general way is first assume the transition to be in saturation region, then find the conditions. Then you get to know your assumption is right or wrong. If it is correct, well and good, question is solved. If it is wrong, then make another assumption. The second assumption should be, it should be in linear region. Then you make that assumption, then solve the question. If you are getting two values, then pick that solution only which makes your assumption correct. So here this assumption was being corrected. So our V naught value was 0.76 volt. In the examination, within 2 to 3 minutes, you will be able to solve these problems. No need to worry. Here I am explaining. That's why it is taking time. Let's move on to the next problem. Solve this problem by your own, then only see the solution. Pause the video and solve this. Yeah, so let's solve this problem. So here they have given the current direction. Current direction is downward. And one thing I know that this is NMOS. Why so? Because arrow is outward. So I know this is NMOS because arrow is outward and current direction is given like this. That means this has to be drain. In NMOS, what is the direction of current? Drain to source. And in case of PMOS, what is the direction of current? Source to drain. That we have to remember. Electrons were going into the drain. So direction would be drain to source. So the current direction is drain to source. So the upper one is drain, lower one is source. First thing I saw that this is NMOS. Second thing I saw that the current is going from up to down. That means drain to source. That's it. And this certainly has to be gate. What is the VGS value here? 3 volt. VT value must be given in the question, that is 1 volt. Let me recheck. 1 volt. Any other information you have? You have the ID, current ID, that is given 150 microampere. So this is the all information you are having. Now to comment on that, you need the value of VDS and you don't have that. So first what you will do, you will assume it to be in saturation region. Let MOS in saturation region. Let MOS is in saturation region. If it is in saturation region, what will be ID? ID will be mu n. I will again and again write this formula so that you memorize it. Mu n Cx W by 2L Vgs minus Vt whole square. What is the value of mu n Cx? Here it is 100 micro. W by L is 10 by 2. Vgs value is fixed minus Vt value is 1. So what do you get? ID value you get is 200 micro ampere. So what did you get to know here? That if the MOS was working in saturation region, the current would have been 200 microampere. But the given current is 150 microampere. That means it is not working in saturation region. What do you do? ID versus VDS curve you have studied, right? If your VDS was such that it is working in saturation region, if your VDS was such that it is working in saturation region, then your VDS would have been somewhere here. Because in the saturation region, the current is maximum. The current is saturated. That means this is the maximum current that it can take. This is the scene. This is the maximum current that it can take, which is 200 microampere. For a particular VGS value, this is the maximum current it can take. VGS is fixed, that is 3 volt. So for a particular VGS value, this is the maximum current it can take. But now it is taking 150 microampere. That means VDS should have been somewhere here, right? This is your VDS operating. Operating means at which this transistor is operating. So this is your VDS operating. So what is that region? Linear region. So your MOS, here you can say MOS is not in saturation but in linear. Did you understand this question? First you solved it, you found the current came out to be 200 microampere. So that you got to know that for a VGS value of 3 volt, this is for fixed VGS, here VGS is fixed. For a VGS value of 3 volt, your drain current should be 200 microampere, but the current is lesser, that means it has to be in linear region. That's it. So this was the first question. Let's take up the next one. What they are asking in the next one, I guess they have changed the data here. 2.5 and 200 microampere is coming. 200 microampere is coming. This is 2.5 volt. And from here 200 microampere is coming. Do you have the idea of VGS value? No. And what will be drain, what will be source? The current is coming like this and it is NMOS, so it has to be drain to source, and this will be gate only. The current will always be flowing in drain to source, right? Yeah. So ID value is given 200 microampere. Do you have the VGS value? Nothing you have. Again, let saturation region. So if it is saturation region, then ID would be equals to ID. Okay, I will write down the formula again and again so that you remember it. ID will be equals to mu n Ux W by 2L VGS minus VT whole square. So 200 micro is equals to, I will write down this micro for sure. 100 micro into W by L is 1 by 2 VGS minus VT whole square. So from here VGS value came out to be 2, right? Not 2, sorry, 3. Yeah, VGS value came out to be 3. So from here VGS came out to be 3 volt. Now your VGS is 3 volt. So if it is in saturation region, your VGS should be 3 volt. But let us check if our assumption is correct. VGS is 3 volt. What is VDS? VDS is 2.5 volt. What will be V overdrive? VGS minus VT. VGS minus VT. That will be 2 volt. Here VDS is greater than V overdrive. That means saturation region. And if it is in saturation region, that means your assumption is correct. Assumption correct. Your answer is also correct. Your VGS is assumption is correct. That means it is working in saturation region only. And this is your final answer. They did not ask VGS value or anything. They just asked the region of operation. And here linear region was the answer. Right? Let's move on to the next one. This is very simple actually. Right? I can solve it here only. Now you will say, sir, now the current direction is not given. How we will decide which is drain, which is source? You can decide, right? If this potential is x, what will be this potential? X plus 4. So the one which is at higher potential, that is drain. In case of NMOS, the one which is at higher potential, that is drain. Do you remember these points? I will revise it once again. ध्यान से सुन लो, ठीक है, सभी ध्यान से सुनेंगे. In case of NMOS, the one which is at higher potential, that is drain. Lower potential is source. The current flows from drain to source, higher potential to lower potential. That's it. In case of PMOS, the one which is at higher potential, that is source, and one which is at lower potential, that is drain. The current flows from higher potential to lower potential, that means from source to drain. That's it. Very easy. You can remember it, right? Yeah. So one which is at higher potential, that means that will be drain. This will be source. Drain, source. And certainly this will be gate only. So here you can see what is the value of VDS? 4 volt. What is the value of VGS? 2 volt. What is your V overdrive? VGS minus VT, that means 1 volt. So VDS is greater than V overdrive. What is the answer? Saturation region. That's it. Very easy, very straightforward. You can solve this one here as well. What is the value of VDS? 2 volt. What is the value of V overdrive? VGS minus VT. Look, you will say that now, sir, gate is at higher potential. While designing drain and source, there is no meaning of VGS value. Only by VDS you are deciding. People may say that, sir, this is at the highest potential, so this should be drain. No, no, no. This will always be gate only. Now the task is between these two. This is at x, this is at x plus 2. So this will be drain, this will be source. What is your VDS? 2 volt. What is your V overdrive? That is VGS minus VT. 4 minus 1, 3 volt. So here VDS is less than V overdrive. What does this signifies? It is in linear region. Well and good. So linear region, saturation region. Okay. Now this question. Here you don't have potential of anything. You don't know the potential of drain, you don't know the potential of source. What will be drain, what will be source? Here you have to assume. If there is no potential given, you have to consider that this will be drain and this will be source, the general form. In previous questions, you had the potential of someone. You had the potential of drain and source, anything. But here you don't have the potential. You have to assume that upper one will be drain, lower one will be source, because this is NMOS only. Because the arrow is outward, this is NMOS only. Here again I will assume this is drain, this is source. Let's assume this potential is X, or forget about X. This potential is VD, this potential is VS, and this potential is VG only. What is the value of VDS here? VDS, that is VD minus VS only. What is the potential of VGS here? What is the potential of VGS? That is VG minus VS. But you can write down VG in terms of VD. This is VG minus VS only. But what is VG? VG is VD plus 1.5. VG is VD plus 1.5. Are you agreeing to this point? VG plus 1.5 minus VS. You can write VGS is 1.5 plus VDS. Are you agreeing to this point? VGS is 1.5 plus VDS. Did you understand this point? Right? VG minus VS, then I write down the value of VG, that is VD plus 1.5. So it is 1.5 plus VDS. And what is VT? VT is 1 volt, that is even. VT is 1 volt is even. What is the value of V overdrive? V overdrive is 0.5 plus VDS. So here what do you see? VDS is less than V overdrive. Are you agreeing to this point? Because V overdrive is 0.5 plus VDS. So it is certainly greater than VDS. So here V overdrive is greater. So what does that implies? That implies that this is linear region because V overdrive is more. VDS is small, that means it is linear region. Did you understand this point? How did I solve it? I just found the value of VDS, VGS and VT. That's it. Here I will have the same target. What is the value of VDS? Okay, before this thing I will tell you one interesting thing, that is, so while defining the saturation region, what do we do? VDS should be greater than VGS minus VT, right? This is what we do. What is VDS? That is VD minus VS. What is VGS? That is VG minus VS minus VT. Source to source get cancelled. So VD should be greater than VG minus VT. That's it. There is no role of source. In case of NMOS, there is no role of source for defining the region of operation. Same in case of PMOS. In case of PMOS, what will happen? VSD should be greater than VSG minus mode of VTP. Right? So Vs minus Vd should be greater than Vs minus Vg minus mode of Vt, whatever it is. Vs would get cancelled. Minus of Vd should be greater than minus of Vg minus of mode of Vtp. Then Vd should be less than Vg plus mode of Vtp. Simple mathematics I have applied. This minus minus sign, minus minus got cancelled, so arrow sign will also change. So this is also the condition. So and these are the conditions. So here what do we understand? That there is no role of source potential for defining the region of operation. But still we write in this manner because it is easier to remember. Here if I had told you these formulas, you would have forgot, okay, where will this arrow sign come, how will the arrow come, when there will be plus, when there will be minus. So this I don't wanted you to go through. So that's why I told this formula VDS is greater than VGS minus VT. But you have to remember that there is no role of source potential while defining the region of operation. Are you getting this point? If your VGS is greater than VT, that's it. If your VGS is greater than VT, then your transistor is on and everything is in your control. Whether it will be in saturation or in linear, you can directly know it by the potential of VD and VG. If it is on, if it is not on, then it certainly depends on source potential as well, because VGS has to be greater than VT. Right? We have understood everything. So here just one interesting point I wanted to deliver, that source has no role until VGS is greater than VT, because before VGS less than VT, the transistor is not even on. After that, if VGS is greater than VT, then only these things will happen. And here by default we consider that VGS is greater than VT. Here we had to consider that VGS is greater than VT. If this was the case that VGS is less than VT, less than 1 volt, then everything that we have studied, that is wrong. There is no meaning of that. So we have to consider, by default we consider that VGS is greater than VT. So I should have mentioned it in the question that your VGS, you need to consider VGS to be greater than VT. Otherwise the transistor will be off. Yeah. So here as well VGS is greater than VT, so your transistor is on. That we have to certainly consider. So your VDS is VD minus VS. What is your VGS? Here what is your VGS? Your VGS is, what is your VG? VG is VD plus 0.5. VD plus 0.5 minus VS. So VGS is VDS plus 0.5 volt. What is VT? VT is 1 volt. What is V overdrive? V overdrive is VGS minus VT. That is VDS minus 0.5. Which one is larger? VDS minus 0.5. Which one is larger? VDS is larger, right? Let's assume VDS is 1 volt. So what will be your V overdrive? That will be 0.5. So VDS is larger. So VDS is greater than V overdrive. That means this is saturation region. Are you able to understand this point? But one thing I should have mentioned, that your VGS is greater than 1 volt. In all these questions here, I will write it with the yellow pen because this is in the question only. Let VGS is greater than 1 volt. So this we have to consider. Okay, well and good. Let's move on to the next problem. So here in the first two questions, what did we learn? We learned about how do we find the region of operation, how do we apply the drain current formula, how do we apply the saturation current formula, right? So these formulas we have applied and then we found the region of operation. Now we will move to better questions. Here you again need to find the drain current of MOS. Do you know the region of operation? Again we don't know. What will be drain? What will be source? Do you know the potential of this point? No. Do you know the potential of this point? No, you don't know. You know the potential of this point? Yeah, but you don't know the potential of this point. We will again consider by the same formula, that is, this should be drain, this should be source. When it will be interchanged, I will tell you in the question itself. But here we have to consider by the general way that upper one will be drain, lower one will be source. Because we don't know the potential of drain, right? You have to find the drain current of MOS. This is the question now. Tell me one thing, what ID will be equals to? Can you write one equation, that is ID plus V naught by 10K plus V naught minus 6 by 20K is equals to 0. Is that equation correct? Yeah. Outward current, this outward current, this is also outward current. V naught by 10K, this is also outward current, or this is also outward current. Addition of outward current is equals to 0. Simple KVL, I am applying, sorry, simple KCL, I am applying KCL at node V naught. KCL at node V naught. This is what I did. I will not call this one as equation 1 because I need to find the ID value. So for ID value, I will write 6 minus V naught by 20K minus V naught by 10K. This is my I naught value. Again, you don't know the region of operation. Again, you have to assume. Okay, so we will start by assuming. What I will do, let MOS is in saturation. MOS is in saturation. Then what will be ID value? ID value will be mu n Cx W by 2L. Now I am not going to write the formula. Okay. VGS value do we have? VGS value is 3 volt. VGS minus VT square. ID value came out to be 200 micro, right? Or 200 micro. So ID value came out to be 200 microampere. Now, if it is 200 microampere, what will be the value of V naught that we can find? So 200 micro is equals to 6 minus V naught by 20K minus V naught by 10K. 20 will go here. 2 into 10 to the power 4. This will be 2 into 10 to the power 4. This will be 4 only. 6 minus V naught minus 2 V naught. 3 V naught by equals to 2. So V naught will be equals to 2 by 3. So what you are getting? 0.67. When you solve this equation, V naught value we are getting is 0.67. V naught value we are getting is 0.61. What is your V overdrive here? VGS minus VT. That is 2 volt. right? V overdrive is 2 volt. Here you can see VGS minus VT, V overdrive is 2 volt. What do you see here? That your V naught is equals to VDS only. This is your V naught. V naught is VDS only. Here your VDS is equals to V naught. V naught, that is equals to VDS. This is lesser than V overdrive. What does this shows? Linear region. If it is in linear region, your assumption is wrong. So the assumption you made, that is wrong. So this ID, this is wrong, this is also wrong. So now again you have to make assumption. Assuming, what assumption you will make? Assuming MOS in linear or triode, linear region. For linear region, what is the current equation? Mu1 Cux W by L VGS minus VT into VDS minus VDS square by 2. So those who are solving it for the first time, मतलब जो पहली बार पढ़ रहे हैं, they, for them it might seem a bit hectic, like so much of calculation is there, how do we remember all these things? But once you practice enough questions, you will be habitual. The only thing you need to do, first you need to consider, then you need to find the parameters. Not satisfied? Satisfied? Good enough? Not satisfied? Assume the other region. That's it. In the second one, it will be satisfied, that's for sure. Right? So yeah. Now you have again two variables, ID and V naught. But ID we have wrote down in terms of V naught only. So 6 minus V naught by 20K, 6 minus V naught by 20K minus V naught by 10K. Also you should have good aptitude to solve the problems. Like calculation should be better. That's why I am showing you all the calculation, because in this kind of question, calculation becomes a very important part. So mu and Cux is 100 micro, so I will certainly write 100 micro. I will not miss that. Into W by L is 10. VGS minus VT is 2. VDS is V naught only, minus V naught square by 2. Right? So here this is 2 into 10 to the power 4. This is 2 into 10 to the power 4. This is 10 to the power 4. So LCM will be 2 into 10 to the power 4 only. Right? So 6 minus V naught minus 2 V naught, and 2 into 10 to the power 4 will be going here, and this is already 10 to the power minus 4. Are you getting this point? So this will be 20 only. 20. 2 V naught minus V naught square by 2. Well and good. Is there any mistake I have done? W by L is what? 1. Yeah, that's what I was thinking. W by L I have taken here also 1. W by L is 1 here, not 10. So this will be 2 only. इतना आंसर तुम्हारे को याद था, minus V naught square. So V naught square minus 7 V naught plus 6. So V naught, 2 V naught values we will get, I guess, from here as well. But you can tell which value I should take. Here I am getting 1 as well and 6 as well. Right? 1 we satisfied over 6, 36, 42, yeah. So from here V naught value we get, 2 values we are getting, 1 volt and 6 volt. If you take this 1 volt, what will happen? Your V overdrive will be lesser than VGS minus VT, right? If I take V naught equals to 1 volt, okay, I will write if V naught is equals to 1 volt, what is V overdrive? That is 2 volt only. VGS minus VT, VGS minus VT is 2 volt. So here VDS is less than V overdrive, that shows linear region. Linear region, and assumption is correct. Assumption is correct. So your V naught value will be 1 volt. V naught value will be 1 volt. But if you take, दो एरो लगा दिए यहाँ पे, if you take V naught to be 6 volt, what will happen? V overdrive will be 2 volt and your VDS will be greater than V overdrive. That shows saturation region, but in the previous part of video we found out that this is not in saturation region. Not in the previous part of video, but in the previous part of solution we found out that this is not in, okay, wait, yeah, this is not in saturation region, right? The MOSFET is not working in saturation region, because here when we assumed it in saturation region, it came out to be in linear region. So this is not, certainly not working in saturation region. So this cannot be true. So the only option true is this. So your V naught value is 1 volt. That's it. Okay. Let's try solving this question on your own. Now you have the enough aptitude. You can take your time and try solving this question on your own. The question is, the MOSFET is working in saturation region. That is given. If it is working in saturation region, what should be the value of Rs? So now you don't have to assume. It is given that it is working in saturation region. What should be the value of Rs? This you need to find. Tell me what is the potential here. Will it be 1 volt? Can you directly say it that it will be 1 volt only? Yes, I can directly say it will be 1 volt only. Why so? Because there is 0 ampere current here. If it was driving some current, let's assume if my circuit was something like this. 4R, R, this is 5 volt, and this is driving some 1 ampere current here. Let's assume this is driving some 1 ampere current here. Can you say this potential will be 1 volt? This is wrong. This potential will be 1 volt. No. If this is not driving any current, then only you can apply the voltage divider. No. Are you getting this point? अगर यहाँ से करंट नहीं जा रहा तभी तो वोल्टेज डिवाइडर लगाओगे. R1 by R1 plus R2 into V in. If it is driving some current, then you can't apply voltage divider. What you will have to do? You will have to assume a voltage V here. So V minus 5 by 4R plus V by R plus 1 ampere is equals to 0. Then you can find the value of V. But if this 1 ampere is infinite, this 1 ampere is not there. If this 1 ampere is not there, then what will be the case? This will be the case. And from here, what will be the value of V? That will be 5V minus 5 equals to 0. V will be 1 volt. Basic network analysis, very basic network analysis. But these kind of concept we will again and again use. People will every time think that we can apply voltage divider, but we cannot apply. We can only apply if there is 0 ampere current. If the node is driving some current, if there are two paths, then you can't apply voltage division. There is only one path. This node can drive current only here. That's it. Are you getting this point? So that's why we cannot apply nodal analysis here. Here we can apply, but if it was driving some current, we couldn't have applied it. So here this potential is 1 volt, right? This potential is 1 volt. Yeah, so 1 volt is fixed here. So what is the value of VGS? Because if it is in saturation region, it is given. We don't need the value of VDS. VDS की वैल्यू की जरूरत ही नहीं है क्योंकि this is working in saturation region. So we only need the value of VGS. What is the value of VGS? That is 1 minus, let's assume this current is ID, so that will be 1 minus ID into RS. Are you agreeing to this point? Why you are agreeing to this point? Because this is source. What is the potential of source? VG we got to know here, that is 1 volt. What is VS? VS will be ID into RS, because this is source, right? This node is source. So Vs would be ID into Rs. So VGS will be 1 minus ID into Rs, right? Vt is given 0.5 volt. Now current equation is given already. So what is ID? ID is, here I can write ID is Kn into VGS minus Vt, because Kn is already defined. Kn is mu n x W by 12. Kn into VGS minus Vt whole square. So ID is 119 micro, that is equals to 4.12 millisiemen per volt milli. What is VGS? VGS is 1 minus 119 micro into RS. This is VGS. 1 minus ID into RS. So ID value 192 into RS minus 0.5 whole square. Now I will directly solve it in gate calculator, or in your main calculator also you can solve. But how will you solve it in gate calculator? What you will do, you will convert this into milli, because milli and milli will get cancelled. So 119 micro in milli, what that will be? 0.119. So 0.119 micro divided by 4.12. 0.119, I guess, I don't think I will be able to show it. So 0.119 milli divided by 4.12 milli. Milli and milli got cancelled. Then I will take under root. So here I am getting 0.169. So 0.17 I can write. This is equals to 0.5 minus 119 micro into RS, because 1 minus 0.5 is 0.5 only, right? Now people will say that Bhaiya, you took the under root, so here plus minus should come, right? Whenever you are taking under root, always take plus sign. We have solved enough question, I have solved enough problems. If I had taken negative sign here, what would have happened? What would have happened if I had taken the negative? So if I had taken the negative sign, what do you mean by that? You are saying that your VGS minus VT is negative. If you are saying, sir, if you take under root, that means plus minus should come. But is that so? Because here you are writing some ID value is there. So ID by Kn under root. This is what you are doing here. And that is equals to VGS minus VT. Now if you are saying plus minus should come. So if it is minus, if you are taking the minus sign here, what will happen? You are saying VGS minus VT is negative. And if VGS minus VT is negative, the MOSFET will not even turn on. So never take the negative sign. Always take the positive sign. So this is one thing that you can note down in your notes, or you can highlight, that you should always take positive sign whenever you are taking under root, because VGS minus VT cannot be negative, right? So many times teachers don't tell this concept, why we are actually taking the positive sign. So positive sign should be taken, that everyone remembers why it should be taken, because VGS minus VT cannot be negative, right? So from here I can directly solve and find the value of RS. Yeah, so in the gate calculator instead I will solve it. Minus 0.5 divided by 119 micro. अरे यार 0.5 minus 0.17 divided by 119 micro into 1000. 2.77 kilo ohm. 2.77 kilo ohm. So this is the value of RS. Well and good. I guess one more question is left. That is also very good question. This was actually very easy question. Just everything was given. You need to find the value of RS. This question also you can try solving. That is a very good question. And where am I getting all these questions from? Because they are NPTEL assignments. From there I am getting these questions. So whatever that is necessary for you, that I am dealing here. Okay. Yeah. So find the bias current in the transistor. So again, ID current you need to find. This value given is 40 kilo ohm. So RR value is given 40 kilo ohm. Now what do you think? This current 100 microampere is the answer. ID is 100 microampere. Is that so? Complete current is coming. Is that so? No. That is true that here there will be 0 ampere current. This is true. But who said current cannot flow from here? Current can certainly flow from here. There will be no current here, but certainly the current can flow from here, right? So let us say this potential is V naught. Let us say this potential is V naught. Then what this potential will be? If this potential is V naught, this potential will be V naught by 2. Say yes or no, right? VDS value is V naught. VGS value is V naught by 2. VT value is 1 volt. Until you know the value of V naught, you cannot decide in which region it is working. So again, you have to assume that it is working in saturation region or linear region. So again, you have to assume. The choice is up to yours. In what region do you assume? Okay. But before that, we cannot have two variables, V naught and ID. So we have to write ID in terms of V naught. So what will be ID in terms of V naught? From upward, 100 microampere current is coming. Here, how much current is going? Can you tell how much current is going in this direction? V naught by 2R. Right? You know the potential of this node, you know the potential of this node. V naught minus V naught by 2R. So this current is V naught by 2R. This current is ID. So 100 micro is equals to V naught by 2R plus ID. So ID you can write 100 micro minus V naught by 80K. 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 So if I want to write it in micro only, 100 micro minus, I will also write down in micro only. So what I can do? 1000 by 80, 1000 by 80 V naught micro. Did you understand what did I do here? I have 1 by 80K. I want to write it in micro. So 1 by 80K is similar to 1 by 80 milli. So if I multiply and divide it with 1000, so what I will get? 10 to the power 3 into 10 to the power minus 3. So 10 to the power minus 3 into 10 to the power minus 3. That will give me micro divided by 80. So this is how I converted it in the micro. Because here the current was in micro. So I needed all of them in micro only. Or I could have converted in milli. This was also a good way. But I thought of making it in micro. This is my ID. So my ID will be 100 micro minus 12.5 V naught micro. This will be my ID. Now what we are assuming? We are assuming MOSFET to be in saturation region. Or I can assume it to be in linear region, because as far as I remember, it will be in linear region only. But since we are following the same method, so let MOS in saturation. This ID that I found, that is irrespective of linear or saturation, right? This ID that I found, that is irrespective of linear or saturation, because I did not apply any ID equation. I just assume ID as a variable. ID will be equals to mu n Cux W by 2L. So 100 micro divided by 2. VGS minus VT whole square. What is VGS? That is V naught by 2 minus VT. What is VT? 1. Right. Now ID I can replace here. ID is 100 micro minus 12.5 micro V naught, 50 micro, that will be V naught by 2 minus 1 whole square. Now micro will get cancelled, right? Micro, it can get cancelled. 100 minus 12.5 V naught, and this is 50 here. This will be V naught square by 4 plus 1 minus V naught. So 100 minus 12.5 V naught. The calculation is a bit complex, and these kind of complex questions are asked in GATE examination as well. You don't think that this kind of complex calculation will not be asked in the examination. It can be asked. Many times it has been asked. So yeah, you should be ready that these kind of calculation can also come. You should have the patience that slowly I can solve these problems, right? So 12.5 V naught I will put here only. Now this will come here, so 37.5 V naught, and this will come here minus 50 well and good is equals to 0. कोई मिस्टेक तो नहीं कर दिया है, बस ये डर लग रहा है मेरे को. ठीक है, minus 50. Okay, 12.5 I can take common, I guess. So this will be 3 V naught, right? I can take common. V naught square minus 3 V naught, 50 divided by 12.5, 12 चौके 48, 4. That's it. What did I do? I took 12.5 common. So 12.5 into 3 is 37.5. 12.5 into 4 is 50. That's it. So from here I can get the value of V naught. Two values I will get, I guess. Let me solve it. I solved it by this method only. So 2 I am getting values are 4 volt and minus 1 volt. Minus 1 volt is possible? No. If V naught is minus 1 volt, what will happen? The MOS will be off only. If V naught is minus 1, the MOS will be off. Because VDS is negative. For transistor to turn on, what is the condition? That VDS should be greater than 0 and VGS should be greater than VT. These are the conditions, right? Two conditions are there. That this should happen. That's for sure. That this should happen. But if you are saying that, your V naught is minus 1 volt, then your VDS is becoming lesser than 0. Then your transistor will be off. But that is not possible. Why it is not possible? Let's assume my transistor is off. Let's assume my V naught is minus 1 volt and let's assume my transistor is off. What will happen then? V naught by 2R will be equals to 100 micro. What will be the value of V naught? The value of V naught will be 200 micro into R. So 200 micro is 2 to the power 4 into R value is 40 to the power minus 4 into. So V naught value will came out to be 8. I am assuming if my transistor is off. Now people may have the doubt that sir, it can go into cutoff as well. Why it cannot go into cutoff? That I am explaining. If my transistor is off, what will be my V naught value? V naught value came out to be 8 volt. And if V naught is 8 volt, what will be VDS? It will be 8 volt. What will be VGS? VGS will be 4 volt. And what will be VT? VT will be 1 volt. So VDS is greater than VGS minus VT. So this will go into saturation only. If you assume your transistor to be in cutoff, we get it to be in saturation. Did you understand that it cannot go into cutoff? So I will write it down. I will certainly write it down. What I will write down? Let V naught is minus 1 volt. That is equals to VDS. That means MOS goes into cutoff. And for now, let's assume that cutoff is an possibility because we haven't checked. We have not checked that cutoff cannot be one of the possibility. Here we eradicated the possibility of being in saturation region in these kind of questions. So here we eradicated those possibility. Why so? Because we have already checked that it cannot be in saturation region. But here V naught is becoming to be minus 1 volt. So there can be possibility that it can be in cutoff. There can be one of the possibility that it can be in cutoff region. So we have to check now. So check. I am writing check. We are checking. If MOS is in cutoff, यार ये पेन का क्या हो गया है? MOS is in cutoff, then what will happen? ID will become 0 ampere. Then V naught by 2R will be 100 micro. So from here V naught will be 8 volt. V naught is 8. V overdrive would be V naught by 2 minus VT. That will be 3 volt. So here V naught is greater than V overdrive. Also this is V naught and what is VGS? VGS will be 4 volt. Also VGS is greater than VT and also VDS is greater than 0 volts. By all these three conditions, MOS goes into saturation. So cannot be in cutoff. So here we checked that most cannot be in cutoff. Now we will take the second answer, that is 4 volt. Now we will take the second answer. So if V naught is 4 volt, if V naught is 4 volt, V naught is 4 volt, that means VDS will be 4 volt only, because V naught and VDS are equal only. What will be your VGS? VGS will be 4 by 2, 2 volt. What is your VT? That is 1 volt. So what will be your VA overdrive? That will be 1 volt only. So here, what is the condition? That your VDS is greater than VA overdrive. That means it is in saturation region only. Initially I thought it can be in linear, but it is in saturation region only. So the assumption is correct. Assumption correct. And if the assumption is correct, so V naught will be 4 volt. So this is the answer. What did they ask? They asked the value of V naught or ID. Or find the bias current. So V naught will be 4 volt. What will be the bias current? ID value they are asking. ID value. So ID is 100 micro minus 12.5 micro into V naught. That will be 50 micro. Because 12.5 into 4 is 50. So ID value will be 50 micro. That's it. Or after getting the V naught value or VGS value, you can find it by the expression as well. This expression. ID equals to mu n CUX W by 12. So mu n CUX W by 12 will be 50 micro only. 50 micro into VGS minus VT. VGS is 2, VT is 1. So from here also you will get 50 micro answer. Or by that equation also you can get. Right? So very easy, well and good. I hope you have understood all the problems. And why did I take this exercise? That also you must have understood. Because here my main task was to make you understand that how do you find the DC parameter, VGS, VDS, VGS minus VT, all those stuffs. How do you get to know about the region of operation? And if you know the region of operation, how to apply the current equation? Then this is how we find. And then we will bias the transistor in a particular region. So all these transistors were biased. What do you mean by biased? Giving a DC supply, that's it. Here you are giving a DC supply 6 volt to the transistor. So all these transistors were biased. So once we bias the transistor, then we will use it in amplifier. Then we will amplify the input signal. Which signal we will amplify, how we will amplify, that we will study. But why did I take this example? Why did I take this exercise? So that you could know how to bias the transistor, then how to determine the region of operation. So that's how we determine the region of operation. The same thing will be happening in BJT as well. So same thing we will study in BJT. So these kind of questions are asked in the examination. So I hope you have understood. So let's meet in the next video. Okay, thank you.